Thanks, Sivia, and thanks everybody for taking a little bit of time with us today. You know, Arthur Conan Doyle once said, "Where there is no imagination, there is no horror." And this is certainly true when it comes to cloud security because, as you're about to see, bad guys can be incredibly imaginative in finding ways to exploit misconfigurations in your cloud environment to do real damage and steal data. And IAM misconfigurations are some of the freakiest of them all. Simulating some of these IAM misconfigurations is Josh Stella, co-founder and CTO of Fugue, and Wayne Crissman, Fugue's Director of Security. And I'll be back later to facilitate your questions, so please get yours in at any time. So grab some popcorn and let's get on with the show. Take it away, Josh.
Thank you, Drew. Thanks everyone for joining us today. It's one of our favorite holidays here at Fugue, and highly appropriate to IAM exploits. IAM exploits have a sort of, they're such an unusual vector for attack compared to what we're used to in the data center that they can be very disorienting. They can be very strange and unexpected in their behaviors. So what are we going to cover today? Here's a brief agenda. Oh, I want to go back to the cover slide. That was cooler. The brief agenda. One, we're going to do an overview of what is cloud misconfiguration risk. And I suspect most of the folks on the call know, but we're going to walk through it a little bit. We're going to go through an overview briefly of the complexities of IAM security. A lot of folks think of IAM as being just users and groups. It's really a network, and we're going to talk about that a little. And then we're going to show you two misconfiguration exploits. I'm going to do a pretty simple one, although as you'll see, that simple one results in stealing a lot of data out of S3. Without much in the way of evidence in any of the detection methods you might traditionally use. And then Wayne is going to do the one that I think is one of the scariest I've ever seen. It is a true cross-account takeover using IAM. Then we're going to go through some tips for identifying and eliminating IAM attack vectors and some Q&A. So what is cloud misconfiguration and how is it a major security risk? Cloud misconfiguration is getting the settings wrong on cloud services. That sounds simple. It's incredibly hard to get right. It is really easy to make small mistakes that bad guys can exploit to great effect. And we're going to show some of those to you. And the result of that is, according to Neil McDonald at Gartner, nearly all successful attacks on cloud services are the result of customer misconfiguration, mismanagement, and mistakes. That sounds a bit accusatory. It's correct, but humans are not great at keeping track of thousands and thousands or even millions and millions of disparate specific settings. We're just not well suited to that. We're better at other things, right? But to eliminate misconfigurations means to keep track in real time, ahead of time. Particularly, we're going to show you these exploits that if you don't prevent are devastating. So it's not good enough to track after the fact. That requires a lot of automation. And actually, that's what Fugue does for a living. So we're not going to pitch you Fugue today. We're going to talk about IAM misconfigurations and show you some exploits, but that is what we do for a living. Last year, we put together a survey, excuse me, of over 300 organizations operating on the cloud at scale, and this 93% is from that survey. This is the number of those organizations that are concerned about a major security breach due to misconfiguration. I think this should be 100%, but 93 is pretty good. Every breach I have ever seen in the news on the cloud is due to misconfiguration primarily. Even the ones that the press gets wrong, where they think it was a misconfigured web application firewall as opposed to the cloud security layer, that was not actually the main part of that breach. Almost all cloud breaches are due to misconfiguration. So again, from the survey, our respondents, obviously these are not exclusive, you could choose more than one. These were the things they were most concerned with. This surprised me and made me pretty happy. 2/3 identified IAM as a major concern for security. That should be, again, 100. But 66 is better than I thought. I have seen a lot of folks who think more in terms of TCP/IP layer security, traditional filtering on IP CIDR blocks and so on, and aren't as concerned with IAM. But those of us who operate on cloud a lot know that IAM forms an alternate path for access to cloud services between the cloud services. And so it is an extremely important and misunderstood vector for attackers, and difficult, therefore, for security professionals to secure. So next in line, security group rules, essentially firewall rules. This is extremely important too. Don't get me wrong. You still need to filter on ports and protocols, especially on anything that faces the internet. Most breaches we see out there are due to a combination of getting in through a port that shouldn't be there and then exploiting things like IAM to get to things like object storage, which is the next one in line. There is a myth that is common that most of these S3 exploits that you read about, these data breaches out of S3, are due to public buckets. They're not. They're due to kind of semi-public buckets and clever utilization of things like IAM and the ability to use IAM list privileges and so on to get access to objects in them. So these are all related. And of course, encryption in transit and at rest, you just do that, right? Use encryption everywhere. But these first three are deeply interrelated. And most of the sophisticated exploits that happen that you read about leverage some combination of these things, as well as others. So how does this happen to people? In the past, bad guys primarily targeted organizations first and then went looking for vulnerabilities to exploit. This still happens. North Korea went after Sony with a spear phishing attack, right? They were intentionally targeting Sony. So this still happens. And if you are at a high profile organization, you have to be very conscious of these kinds of attacks. But the vast majority of attacks we see now in the news happen in, that's kind of the before cloud way. In the cloud era, the mechanism by which attackers decide who to go after has inverted. So these days, the bad guys are using automation to identify vulnerabilities on any public-facing IP address or DNS record. A good friend of mine does a lot of red teaming, is very up to speed on what's happening in the hacker community more than I'm a software architect and developer, CTO now, but that's my background is software architecture and development from a security perspective. He's very tapped into what the bad guys are doing. And he told me the average length of time between an IP address or a DNS record pointing to an IP address going on the internet and it being scanned for vulnerabilities is 7 minutes. So you have minutes to close vulnerabilities. What that means is, and then what the bad guys do, they just run automation 24/7, collect a bunch of things that are exploitable, and then they go kind of shopping through those. And if you look like an attractive target, they'll say, "Ooh, I'm gonna go after this vulnerability I see at Acme Corp." So what this means is the bad guys are fully automated, and that means you have to be too, because humans are much, much slower than that. And by the way, they're not just looking for things like unpatched, servers that have known vulnerabilities in their in their operating systems or applications they're running. They're also looking for these cloud misconfigurations that we're going to show you. So we're going to do a simulation of blowing up S3 security with IAM. So a lot of folks, I mentioned earlier, a lot of folks have this kind of wrong idea that a lot of or even most or all of the S3 breaches we see are due to S3 just being left public. That does happen. It's more rare now than it has been. But a lot of times it's more nuanced than that. We did a webinar recently, a couple of weeks ago, talking about the details of S3. In this one, I'm just going to take a kind of piece of that and show how I can use IAM to exploit an otherwise secure S3 bucket. Oh, I'm flipping the wrong monitor. Okay, so what I'm going to do in this demonstration, this is a visualization of some cloud infrastructure. Fugue does all this automated visualization for you. What I'm going to do here, over on the left is the internet. Here is a VPC network with an internet gateway, and in there is an EC2 instance. And my exploit is going to start from having shell to this EC2 instance. Put another way, I'm taking a shortcut for the purpose of demonstrating in a relatively short period of time. You can read about lots of ways folks gain access to EC2 instances. But important to note, all I need is shell. I don't need root. And once I'm in this EC2 instance, what I'm trying to get to is over here, right? Most EC2 instances in kind of cloud native environments don't contain much of any value to bad guys other than access to things like S3 buckets that contain all the data. And the way they have that access is generally speaking through their IAM roles. So let's take a look at this EC2 instance in the AWS console real quick. Here's my demo host, that's the EC2 instance. And you can see down here, there is an IAM role, in this case called maintenance role, on this EC2 instance. So for folks who aren't familiar with this, what it means is I can define, and let's take a look at maintenance role, I can define what that EC2 instance is allowed to do in my cloud infrastructure, not by giving it TCP IP paths and logins to things with usernames and passwords, but by assigning it a role that gives it access to certain services. So in this case, this is a pretty liberal role. I wouldn't recommend a role like this in production. It says maintenance role, so this might be something you would use during a maintenance window on a jump host. But it has full access to EC2, full access to IAM. With S3, it says full read-write. So that's not full S3, that's somewhat limited S3 actually, which we'll show you. And access to STS. Again, this is a demonstration using a kind of broadly permissive role. Before I go any further, some of you might be saying, and when I do these kinds of presentations live, a lot of times somebody will shoot their hand up and say, Josh, that is against best practices on cloud. We would never do that. Why would you have an IAM policy like that? That just simply wouldn't happen. So I want to paint a picture for you of a scenario where this does in fact happen. And by the way, some of the most capable organizations on cloud have had breaches due to just this kind of thing. So imagine for a moment that you are the on-call engineer at 1 o'clock in the morning, and the general manager of the European branch of your company calls you and says, the system isn't working and I'm trying to get a contract signed right now, fix it. Now you know that system that she's referring to uses a bunch of AWS services. Okay. Well, if I go to the IAM policies that are existent in my account, there's a number of them. There's a large number of them. And these are all AWS managed ones. But in any normal production account, this is just my demo account, you would see a bunch for that individual organization. But if I'm on call, I might try one of those. And then if it doesn't work for me, I might start trying to do some other things. So let's say I know I need to get into EC2. So I'll go to EC2, and I've walked in so far with the very best intentions. I'm going to use them as limited permissions I can. I'm not going to check everything on EC2. By the way, don't do that. Instead, I'm going to go through these access levels and start selecting permissions. But I don't want to select too many permissions, so I'm going to take a look inside of list. So this is a single AWS service, EC2, and these are just the list commands, of which there are 98. These have interdependencies, and not just amongst themselves, also between themselves and other AWS services in IAM. So some of these are, described fleets. I probably don't need that, but in order to do my job, for me to actually get least permission is a pretty big job. Let's take a look at write. How many are in write? Oh, great, 234. So we're north of 300 different permissions needed, or available rather. And we don't know what the subset that's needed is. It's 1 a.m. and there's $1 million deal breathing down our neck. This is how we get overly permissive IAM roles. I've made a kind of caricature example of being called at 1 in the morning. Often this happens in the normal day in, day out use of cloud. People just get a little slack because it's complex. So once that IAM role is out there, and let's jump back to EC2, once that IAM role is out there, that maintenance policy role, that's available to the entire account. So if I'm in an AWS account with 100 other or 500 or 10 other engineers that are doing operations in that account, I have now created something that any of them can use. And I have no way to know how and when they will use it. Similarly, all of your colleagues who are operating on the AWS accounts with you might be creating IAM policies and roles that you're unaware of. And so this becomes a really difficult attack vector to fully pin down by just restricting IAM. Okay, so I'm in maintenance role. I'm on this host, and I'm trying to get to this S3 bucket, right? And we saw that I have S3 read write on maintenance role. But what I don't have is what a hacker really needs, which is the ability to list S3. So I'm going to jump over to a terminal now. And by the way, this webinar is going to have a lot of terminal time. Both I and Wayne are going to spend a lot of time while we're at the terminal explaining exactly what's going on. And I hope that those of you who are less technical will hang in there, because I think it will make sense as we explain it. Those of you who are more technical, we're going to drill down pretty deep. So I've actually already logged into this EC2 instance. I just pretend like the bad guy has access to it. Probably the first thing I'm going to do is a listing of S3 buckets. Somebody did their job right. I can't list those buckets because in that maintenance role IAM role, if you recall, I don't have any S3 list permissions. I have read and write, but I don't have list. So I can't even see what buckets exist. I can't see that there is a customer records bucket, okay? So we'll come back to this, but a point of best practice is if you're running EC2 instances or other infrastructure using IAM roles, be very careful of list permissions. Those are discoverability of your infrastructure for bad guys. All right. So if I'm a bad guy, I'm a little thwarted right now. I'm feeling a little frustrated. So I'm going to start to try to get a lay of the land. My first and most obvious attempt at things didn't work. So I'm now going to call the EC2 instances metadata service, which you might have read about in the news as a terrible and bad and scary thing. It's actually a great and awesome and wonderful thing if you use it properly. What it does is it allows you to get information about your compute infrastructure without having to embed things like secrets inside of it. And by the way, that is one of the biggest attack vectors, is people finding credentials that were put in files and then on file systems in compute instances, and then those were backed up and somebody lost track of the snapshot, and credentials that aren't being rotated get found and people attack with that. That happened 2 weeks ago with a more than 2-year-old EC2 instance where somebody broke into a major, actually security company, used credentials that were stored on the disk of an old EC2 instance to reconstitute an old database and steal customer data. If they had been using IAM and using the metadata service, that would not have been possible. So the trick here is to use it properly. So I just listed kind of a top level directory of everything in that metadata service. I'm going to drill in a little more. Oh, by the way you access metadata, it's just a web server. So I'm using curl here, and I'm going to 169.254.169.254 and just grabbing some security credentials out of there. I can see that I am in maintenance role, as I described before. So I'm going to go get all the security credentials out of maintenance role. Okay, this looks really scary. I've got an access key and a secret access key, but that access key and secret access key did not allow me to actually list S3. Now we're doing 2 demos today, and I'm realizing I'm running long. So I'm going to jump from the terminal, and I'm going to take a shortcut in the console, and I'm going to do something that you should be aware of that can be done. So I can do all this at the command line if I'm a bad guy just by typing a bunch more commands. But instead, I'm going to take this instance, and I'm just going to move its IAM role from maintenance role to S3 read write. And now that EC2 instance, and again, if I'm a bad guy at the command line, I could have done this in about 5 more minutes of hacking around here. But now I have the ability to list S3. There's my S3 buckets that before I couldn't see, right? Here's customer records. So this customer records bucket is actually quite secure. I've gotten to it by doing a lateral movement across IAM roles. So now I'm just going to steal all of the data in that real quick by running one command. I'm going to take everything in customer records, and I'm going to move it, copy it rather, to all your base, which is my own S3 bucket, where I'm going to go and retrieve that data. I just stole all the data. Now that didn't take too long. And it also didn't traverse any TCP/IP network locations where I might have seen the traffic, the packets going, because it was an S3 to S3 copy. So this is how a number of S3 exploits that you've read about have happened. I broke into this EC2 instance. I surfed to another IAM role, and I grabbed all the data out of S3. And I hope that shows how these things actually work together. So I'm going to wrap up my little simulation there because, I was supposed to show walking on the tightrope slide, but I skipped it. I already walked the tightrope, and now I'm going to hand it over to Wayne to do the really scary one. Wayne, take it away.
Thank you, Josh. Let's see. Yep, just need to share my screen. And hopefully by now it's coming up. So let me, Okay, so what I'm going to start with first is some acknowledgements. Just want to give a shout out to Rhino Security Labs. All of the attacks, the methods, the tools that I'll be talking about and using came from their blog. They're a really good account to follow if you're concerned with AWS security, and if you are a customer of AWS, and especially if you have customers of your own, then you should be concerned with that. They're a great one to follow. So there are a few variations of this particular kind of attack. Now I'm going to focus on the simplest one, which is the second blog post you see there, enumerating your IAM roles using assume role. So we're going to just start diving right in and talk about how and why are we vulnerable to this attack. So AWS IAM roles, just like all AWS resources, are identified by their ARN. And an AWS IAM role ARN looks like, oops, too fast, looks like this. And there's only a few things that you actually need here. So AWS IAM is a global service, so region disappears. And so all that's left to fill in detail-wise is account and the role name. And as I started to kind of work this slide up, I started to try to show what a hacker or what an attacker might think like. And so they match, that information matches these regexes, and you'll see where I was going with that in just a second. What I eventually came to was that the account number is somewhat discoverable. I thought maybe it's guessable. Maybe I can figure out valid account numbers. But it turns out that's actually kind of difficult. There are a trillion combinations. There are simple and complex ways to generate 12-digit numbers. I tried a very naive approach, and I didn't get any hits over about 1,000 numbers, so I pretty much ruled that out. So then I started to dig into, well, how can I find these things? And Rhino talks about this as well. You can find these a number of ways. I'm going to jump out of the slideshow and jump over to Firefox here and show some ways you can find this. You can find account numbers. So if I literally went to Google and typed AWS error message, and one of the first hits that I got is an account number right here that is actually valid. I verified, and it's a real account number. I can go to Stack Overflow and just look for folks who are trying to just simply find some help and find valid account numbers. Same thing with GitHub. People just posting issues. I can find account numbers that way. I'm sure if I looked hard enough, I could find role names, but I didn't go that route. And then in the AWS console itself, now these are public AMIs. There are several different things that you can share publicly. And when you share something publicly in AWS, you reveal your account number. So there are legitimate uses, but this does put you to some amount of exposure. This is giving me, many thousands of account numbers that I could just write a script to grab all of these and try some of these methods against, try this attack against. You might have private resources that you shared with other accounts. You've not made it public, but you're still exposing yourself, even though you have a valid reason to. Once that number is out there, even to someone you trust, you have no control over their control of your number. You might use cross-access account, the cross-access account functionality with a vendor, and same thing goes there. So why do I say here this is guessable? The reason this is guessable is because just like any string with a known length and a known character set is vulnerable to a dictionary attack. And so that's what we're actually going to do. We're going to, using some discoverability and a dictionary attack, we're going to hop into an account, and we're going to show how we can move laterally through an organization. So let me set up the stage here. So what I have here is an account that I'm about to show you on another slide in just a second. It has this role ARN with this account number that I've discovered in some way or another as an attacker. It's called cross account access. It's might seem a common name. You might have cross admin access. You might have cross account. Any variation that can be captured in a dictionary. And it has this policy because this is a developer account that I've just set up. And I just have administrator to allow my fellow developers to access this account. Now, where the tricky part comes in, or where the vulnerability actually lies, is in this tab right here. You saw this tab a minute ago under with Josh, and here we're going to look at trust relationships. So, excuse me, a trust relationship, you can of course read the docs, but it basically is saying that anybody inside of this account, any user in one of these accounts can assume this particular role. Now, where does the problem lie? Because this looks okay, right? The problem lies in the ability of being able to do this. You can say AWS star, which means that any AWS account can assume this role. So I need just these three things. I need the account number, the role name, and then I need a misconfigured IAM role that is too broad. So we talked earlier about IAM being kind of like a network. Think of this as opening a firewall rule that's way too broad. Like I've just opened this to the world, right? So I'm going to click Update Trust Policy. Now, AWS, in their defense, they tried to tell you, look, this is a bad thing, but I don't care, right? So now I'm vulnerable to this particular attack. So I'm going to jump back here and I'll show you the layout of what we've got and what we're going to walk through. So in this very poorly drawn whiteboard drawing, excuse me, this is me as the attacker. This is the account we were just in. And what we have here is a 3-person dev team set up in a full mesh configuration, sharing account resources using cross-account roles. And we also have one developer who has a super dev who has some access to prod. Maybe they push code, maybe they retrieve customer records, maybe they download customer records for analysis. Who knows? But the point is that this is a production environment that may or may not contain some PII. It may contain credit card numbers, may contain customer account numbers. It could be anything that's important to your organization. So I'm going to refer back to this diagram quite a bit as we're walking through, just to highlight where I am in the process. And I threw this up just to show how things can get very complex quickly. The more developers that we add to this organization, the more lines of the more entries in that trust policy, and where the temptation starts to become more greater, rather, to just say, you know what, I'm tired of updating this thing. I'm just going to do star. It'll work for all future accounts in our organization, and I'm going to move on with my life. So this just goes to show you how quickly things can get complex. So we're going to just start diving right on in. So you should see a console window. Excuse me. And so what I've got here is, let me clear the screen again. First, I'm going to establish my identity. Okay, and this is in fact the account number that my attacker has, and this is the user that I set up. So, like I said in the diagram a minute ago, we're here. So now, what are these tools from Rhino Security Lab? So I'm going to run this script, and it's going to tell you a little bit of what it needs. So I need an account ID. I need a word list, which I'm just using the default, and I'll show you what that looks like in a minute. And I need this profile, which I'm already using. And I'm going to jump over here to code editor, grab this account number that, again, I have discovered, and I showed you this in the console just a second ago. And I'm going to fire this off. So while this is running, as you can see, starting role enumeration, let me show you what I'm doing, or what the tool is doing, rather. Using some small 120 lines or so of Python code. This code is going to walk through a dictionary of 1,200 words, excuse me, and essentially build an ARN of an IAM role and attempt to assume it, attempt to assume each one of these. And so you might be thinking, okay, well, I'm going to just alert whenever I discover a large number of assume role calls, and I'll move on with my day. So let's think about our methods of generating alerts. One of them is CloudTrail. There are two problems with that philosophy. One, CloudTrail can take up to 15 minutes for logs to hit that service. I'm going to be in and out. If I was an attacker and I came with a set of scripts and I wasn't trying to explain things as I go, I'd be in and out well within 15 minutes with all of the data that I'm going to try to find. The other problem is that this particular attack will not log any denied attempts or any failed attempts at assume role. And I'll show you that in a little while. The only entry in CloudTrail that we're going to see later, hopefully we'll see later if CloudTrail is being nice to me, is the one successful assume role call that that I get. So let's see if the script is finished. And sure enough, we did find one. We found a role that we were successfully able to assume. And you all saw this block a minute ago. So I got some scary looking stuff here: an access key, a secret key, and a session token. So what I'm going to do is I'm going to copy this. I'm going to stick it into a file. And I just wrote a simple little shell script to just grab out the pieces that I need, so you don't have to watch me type a bunch of export commands. Clear the screen again. And I'm just going to run creds.sh. Okay. All right. So these are the credentials that I just got. So let's see who I am. Okay. If you remember, my account number before started with 8. I'm now in one that starts with 1 and ends in 662. Those are minor details that I'll continue to point out. I've assumed a role called cross-account access. And this is just a role session name. It can be any string at all. The tool just gives a random string that is basically meaningless. So if I go back to my diagram, now I'm here. I'm now sitting in this account. And if I were an attacker, I would come armed with several scripts that would go and perform a series of investigation looking for anything useful. But instead, I'm just going to use S3LS as a stand-in for that. I didn't find anything. So as an attacker, I don't know what's going on here. I don't know about this configuration, but part of my script, or part of my investigation, would go and look and try to figure out where this user's been going. I'm going to grab this command right here, and this would be part of my tool set. So what this is saying is to use CloudTrail in the account that I'm now sitting in to look at any events that have an event name called switch role. And switch role, if you're not familiar, it uses the same mechanism as assume role, but it allows you in the console, in the AWS console, to switch between accounts. So anybody who has a trust policy with another account can use switch role to jump into that account. So we're going to go look there. And let me just turn on some highlighting. So as an attacker, looks like I'm getting some hits, so there might be something useful here. I'm going to look for switch 2, because as an attacker, I know that that's useful. And I can see that this user in the AWS console has been moving to yet another account with the same role name. So I don't even need the tool anymore. I don't even need I don't even need to try to guess. I have everything I need now. And I know that this has been successful in the past. So I'm going to assume that role. Oops. There's my role ARN. And I said before, I'm just going to call this one foo. And it looks like this worked. So I'm going to do the same trick. Jump over to my code editor. Give these new creds. And I'm going to see who I am. Okay. And I'll tell you you can see the account number is a little different. The last one ended in 662. This is 108. And by my diagram, I'm here. That's this account. Now, as an attacker, again, I don't know that. All I know is that I'm starting to move laterally through what appears to be some kind of an organization. And now I would just do the same thing. I would run my series of scripts looking for anything interesting. Nothing there. Again, part of that is going to be looking inside of CloudTrail to see where this user might be going. So let's go check that out. And again, I'm getting some hits here. I'm going to look for switch 2 because as an attacker, I know that's the thing that's interesting to me. Don't know why. Ah, here we go. Sorry, it's just breaking across multiple lines. So this is actually looking pretty interesting. There's a different account starting with 29 that has prod in the title. So that's super interesting. Why don't we go there? And I'm in. looks like that was successful as well. So I'm going to take this same stuff, excuse me, these same credentials rather. Oops, I of course copied instead of pasted. And see who I am. So I'm now in this account with this set of permissions, which I still don't know yet. And if I go back to my diagram, now I am here. I've now pivoted into what I don't know as an attacker, but looks promising, is a production account. And it has S3 in the title. So I'm gonna run my series of scripts again, and I'm actually getting something. I have a set of company customer records here. So I'm gonna use the same trick that Josh did, but I'm gonna do something slightly different. As an attacker, what I would do next is create a bucket in an account that I control. I would create a bucket policy that allows this account here, write access to that bucket, and then I would just simply perform sync command. I don't even know it's in this bucket, but I know it's interesting because it's in a production account. I believe I called it your info. And just like Josh showed earlier, I now stole your data. I now stole everything that's inside of here. You could imagine, obviously you can tell by my titles that these are cat pictures, right? But you can imagine this being a series of customer account records of, excuse me, like I said, account numbers, credit card numbers. If you're a bank, you might have social security numbers here. You know, this is the kind of stuff that hits the news. So I've actually came and got a lot of good stuff, and it's getting back out is as simple as setting some environment variables. Oops. And now I'm back to my account again as an attacker. And inside of my account is now everything that's inside of your info. So I now have all of your data. And I wasn't exactly timing it, but let's see if anything has hit CloudTrail. Go. So I'm looking at all events. Oh, here we go. I didn't type it all out. That's part of the problem. So the original call, this is looking for anything by the event of assume role, which is what I did as the attacker to get into this account. And that's the account we're sitting in right now. I'm looking at anything from yesterday that has the event name of assume role. Ah, here we go. They literally just hit, and I already have the data, right? So this, I believe, this is where I went. And so that means this first one should be the one. Yeah, this looks about right. So we even just happen to see, I've already got everything I need just by moving through this organization. I stole some production data, and the first and only assume roll call, I guess first of one of three that you will see that will not trip any alarms, that looks like completely normal traffic, has finally just hit CloudTrail, something that you might be monitoring. And I'm already out, I'm already done. So that just goes to show you that CloudTrail, you know, for as good as it does, I can get in and out long before it even tells you that there was even a hint of something going on.
And Wayne, just to piggyback on that for a second, CloudTrail doesn't have a formal SLA in terms of how responsive it will be. AWS says it takes around 15 minutes, but we've seen it take hours at Fugue. So one of the things we've actually baked into our product is the ability to do things like detect assume roles and revert them, undo them within a few minutes, 5 minutes or, you know, roundabout, because these kinds of attacks really have to be prevented. Knowing they happened after the fact just means you know that all your data is now gone. So prevention is worth far more than a pound of cure here, and no log is going to help you prevent these things. So sorry to interrupt, Wayne. I'll turn it back over to you.
No, that's quite all right. I was actually just about to kick it back over to you. That's really the end of the demo. And like I said, I'm already out. I've tripped basically no alarms. And just like Josh's attack earlier, I didn't cross any network boundaries that might alert traditional networking tools. This was, again, another S3 to S3 copy, just all along the AWS backplane. So nothing has traversed any VPCs or any network. And I didn't need any networking to do it. I could have done this from an EC2 instance or just anywhere, but I did it from a laptop over a VPN, you know. So that's actually, Josh, I'm going to kick it back over to you.
Excellent. Thank you for going to the next slide. So a couple of points there just before we get into preventing. What Wayne just described, we showed you two different exploits. Both of them were trying to go for S3. We could have as easily gone for RDS or DynamoDB or anything that takes IAM credentials, right? We're just surfing IAM to find ways to exploit sources of data, to get access to those things, you know, illegitimately. And you can see that this is entirely possible. And we showed you two different kinds of lateral movement today with IAM. One is within an account, and that's bad enough. But the other is across accounts. So when you think about your security posture in the cloud, I would recommend that you think about it in kind of two ways at the same time. One, you definitely want to do things like constantly review your IAM roles and policies, particularly those that are assigned to resources that are running in your environment, and you know, follow the principle of least privilege. But there are some other mechanisms. S3, for example, has something called bucket policies. And when Wayne was doing that attack from his laptop, he was coming in from an external IP address. So the first bullet here, use S3 bucket policies. You can set up a bucket policy on AWS that limits the IP address CIDR blocks that have access to that data, no matter what IAM permissions they have. So things like that are really worth looking at. So you've got the, I need to make sure I keep track of all the permissions I've granted in the form of IAM, and then look for ways you can kind of throttle that back no matter which permissions are granted for things like S3. List access is dangerous. It is extremely dangerous. And you need it as, you know, my kind of rule of thumb is you need to know everything in your environment. By the way, you probably don't. Most cloud users simply are unaware of all of their infrastructure, who's running it, how old it is, et cetera. That's why in Fugue we have the visualization capability so you can go see it. But you need to have perfect visibility, and then you want to deny the bad guys any visibility, because that knowledge of the terrain, of the topology of your cloud infrastructure is what they're looking for, and they're looking for any cracks in it. As Wayne showed, going from dev account to super dev to prod, you can't even feel like your dev accounts don't need to be secure, because if they have relationships, even indirectly, to production accounts, you need to be aware of those. And those actually are paths that can be traversed. Do not use AWS Star. Avoid cross-account access wherever possible, right? You do need to use cross-account in some cases, but when combined with AWS Star, we just showed you a pretty devastating attack based on that combination. EC2 instances aren't necessary to get hacked or lose data. Wayne just showed you stealing all that data from his laptop by leveraging those credentials. In some cases, again, with things like S3 bucket policies, you can prevent that. but don't think if you're not using EC2 you're safe. AWS account numbers are semi-private. Just consider them public. Security by obscurity never works. Bad guys are clever. Someone in your organization has somewhere put probably an AWS account ID in something that went outside the organization. It's going to happen. Changing account IDs is really hard. It's not something, you can't rotate account IDs, right? You'd have to move all of your infrastructure and recreate it. So just assume they're public and believe that every bad guy in the world has them, because they probably do. CloudTrail is not going to help you here. It might tell you after the fact that you've been hacked, but it will not prevent these bad things from happening. And because these attacks can be so devastating and S3 is so fast, as with the attack a couple of weeks ago, where an RDS, I find this one really interesting. The attacker broke into an old EC2 instance and created a new RDS database out of an old RDS snapshot to steal data. That's something that could never happen in the data center. Build a new database cluster in 30 seconds. So these are the kinds of things that the bad guys are doing now. Why don't we go to the next slide, Wayne? So just to wrap up before we go to Q&A, this is what Fugue does for a living. We just released a bunch of policies, which are Fugue's way of telling you where you're vulnerable, that cover everything we've shown you today, among a lot of other things. So it takes about 30 minutes to try Fugue out, and you can go and point Fugue at your accounts and find out if you're vulnerable to these kinds of hacks we showed you today in just a few minutes. And Drew, why don't we kick it back over to you for any questions?
Thanks, Josh. Thanks, Wayne. Got a few questions here and not a lot of time. So we will reach out to you individually if we don't get to your question, we promise. Jeff asks, and I think this is to Wayne because it came in during your simulation, Wayne. How does S3 encryption work in this scenario? If encryption at rest when copied, does the attacker have read access or access to a key to decrypt?
So by default, when you create, so this is assuming a best practice of encrypting objects at rest using AWS KMS. And AWS KMS keys, when you create one, by default, they're trusted by the account, which means that you are offloading that responsibility to IAM. So that means in that scenario, if you don't change the key policy, which is just, it's written like IAM, but it's specific for KMS keys. If you don't update that policy, it says that anything within that account can essentially use this key. And then if you have an IAM role that allows you to perform decryption, then that will allow an attacker to pull the object, request it to be decrypted, and all of that succeed, and then get the plain text version. So you can secure this a little bit more by updating the key policy. You can restrict that to certain principles within the account. And that's one way to do it. Another way is to be very stringent with who gets the ability to encrypt and decrypt to perform cryptographic operations with the key. So that's definitely another strategy to help secure your environment.
Okay, great. Another question. We're using guard duty. Can that help us identify failed assume role calls?
I can take that one. So I'm actually glad you asked. I should have mentioned this during the webinar. You're right to say that guard duty looks for suspicious and unusual API activity, but out of the box, guard duty has no findings for this particular attack. So even guard duty is blind to an assume role attack like this.
Okay.
If I could piggyback on that. So actually, this is one of the things we designed Fugue to be able to do. Guard duty out of the box won't do this. With Fugue, it's pretty easy to set up an environment, what's called a Fugue environment, where any change in IAM roles is not only alerted on very quickly, but Fugue can actually revert it automatically. So, so it is possible to guard against this in a much quicker time frame than, you know, looking at logs and, you know, creating a ticket for someone to go look at. This can all be automated using Fugue.
Okay, great. Is Lambda susceptible to some of these kinds of attacks?
So Lambda, yes, in the sense that Lambda uses execution roles that are essentially IAM roles, and you can allow a trust policy with Lambda as well. So it's vulnerable in the sense that you could use a star policy for Lambda execution roles. Yeah.
Okay, great. It looks like we're out of time. We ran a little bit long. We will get to a handful of your questions directly via email. Thank you again for taking the time with us today.
Thanks, everyone. Happy Halloween. No, go ahead with it, Drew. That's good. Fugue.co/go. You can try our product and reach out to either Wayne or I directly, and we're happy to chat.